Alright, so we're going to talk about probability. What's the probability of getting a 5-card hand that consists of all diamonds? So I want a probability of diamonds. Remember, it's what I want over what could happen. And because I don't care about the order, I know I can choose a combination. Now, in this case, how do I get, or I want a diamond. So there are 13 diamonds in the set. I want 5 of them. So 13 combination of 5. So I put 13 factorial over 5 factorial, 13 minus 5 factorial over what could happen. So there are 52 cards. I want 5 of them. This is what could happen. So 52 factorial divided by 5 factorial times 52 minus 5 factorial. What you end up getting is these 5 factorials cancel out, but what you end up getting is 13 factorial over 8 factorial and 52 factorial over 47 factorial. And when you put that in the calculator, you end up getting 0.000495. On this next one, you have 18 numbers, 8 names, 10 women, right? You want how many committees of 5 people? Well, I don't really care about the order, so because I don't care about the order, I'm going to use a combination. So I have 18 people. I just want to choose 5 of them. And using our formula right here, it turns out to be 8,568. This is what it looks like in the calculator. Okay? Now, in this next section, if a committee of 5 is chosen at random, it's probably a committee that is composed exclusively of women. So I only want women in this case. So what's the probability of 5 women being chosen? So I don't really care what order, but because it's a probability, we're going to do it just like number 1. So there are 18. We want to choose 5. I'm sorry. There are 10 of them. 10 women. We're going to choose 5 of them. All right. So this is what I want. I want a woman. So there'll be 10, and we have a combination of 5. So I want 5 women. Now, what could happen? Well, I have 18, and I'm going to choose 5 of them. So I'm going to choose 5 people. So in this case, what you end up getting is 10 factorial over 5 factorial, 10 minus 5 factorial, over 18 factorial, over 5 factorial, and then 18 minus 5 factorial. And when you put that in the calculator, what you end up getting is 0.0294. All right? Now, this next section, in many lotteries, one of the games involves matching 6 numbers from 1 to 50. Well, we know that this is going to be 50. Now, I don't care which order, so it's a combination. 50, and it's a combination of 6. But because it says in many lotteries, one of the games, that's going to be one out of this combination right here. So this one out of this combination right here. Okay, so now on this one, because it's in mini lotteries and one of the games involved in, we always say it's a chance of 1 in blank blank, 1 in a million chances. Well, in this case, we want to know if numbers from 1 to 50. If a player selects one particular 6-number combination, what's the probability that that player wins in one of these lotteries? Well, in this case, we're going to play it just like that. So 1 over, and basically it'd be 1 over. This would be 50 factorial over 6 factorial, 50 minus 6 factorial. And what you end up getting is 1 out of 15,890,700. And you do this in the same way. What if we increase it to 55? Well, you just change this number to 55. Combination 6. So it equals 1 over 55 combination of 6. And what that ends up doing is getting 28,989,675. All right. Now, suppose that you receive 5,000 for A. That's this, or 5 million for A, and then 8 million for B. All right. Under which of the scenarios would you expect to do better? Well, simple. You just take 5 million and you put it over your 15,890,700, and you end up getting a ratio or a decimal of 0.3146. And then if you take your 8 million and you put it over the 28,989,675, you end up getting a return of 27 cents, 0.2767. And so which one is better? Well, this one is clearly better. So 31 cents as opposed to 27 cents, even though on this one it's the payout is less. So even though this payout is less, uh, you do better by having fewer numbers. So A is better because of the return, because of the amount of money won, even though it's less numbers. So sorry about that. I didn't have it down here. So again, uh, 1 out of 15,890,700. This is 1 out of 28,989,675. And this one is you find the ratio, it comes out to 0.13146. This is 0.2760. So A is better because of the amount